Hi, welcome. This is maybe a little bit different kind of conference. Well, it's something live. I am going to show you how to run Kubernetes at the edge using K3s. My talk is called Monitoring Weather at the Edge with K3s and Raspberry Pi's devices. So we are going to measure the weather on Tampa. Well, just let me, okay. So IoT and edge computing, well, they are not the same things. IoT, well, the people refers more to devices connected over the internet, but edge computing refers more that processing the data near to the edge. But maybe the difference are like where you are going to process the thing, what type of devices you are going to use, but in reality, IoT and edge computing are complementary. So maybe in edge computing, you want to distribute the information across different devices and in the cloud, some part. And IoT refers more like getting that information with sensors with just small devices. Well, that's IoT. IoT and edge computing are different things too. IoT is more like process one task at a time. Edge computing, you can process different tasks at the same time. You need maybe more power for processing the things and everything. IoT uses microcontrollers. Edge computing uses microprocessors. That's the difference. Let's say that in edge computing, you are using microcomputers. And in IoT, just devices with sensors in general. Something that is common right now is that in edge computing, a lot of people is using ARM because ARM doesn't consume a lot of resources, talking about energy, and has like a kind of reasonable way to process the information and about how many power you are consuming. As we mentioned, IoT and edge computing are complementary, but we can say that edge computing is like the next step of evolution of IoT. In reality, are complementary, but as you can see, a lot of people is saying like edge computing, edge at the edge, and that kind of terms. But well, talking about technology, some people is like referring IoT and edge and the edge term as the same thing. So, well, it's not true, but they are complementary. So if we say that edge computing refers more to process the data near to the source, let's say that, for example, I have a smartphone here and I am generating the information here, I am going to process the information on my device, on my smartphone. Maybe it's possible that that information, I can send some portion of that to the cloud, some portion of the information locally, and I can complement that system with all that information. Maybe the information is in a lot of different edge or local devices, maybe we can say local, and that information is processed locally. When the device finishes to process the information, maybe that information is going to move to the cloud. Maybe you can check that information later in another location, maybe in another country, or maybe you want to create a dashboard with all the information about different edge devices on different locations around the world. That's the reality. So some edge computing use cases could be like smart farms, smart gardens. Let's say that, for example, you are trying to play a little bit with ARM devices and that kind of things. Maybe a cool use case to try could be like a smart garden, something to control your plants and flowers at home, just to measure the weather. And well, it's a little bit dry. I have to put some water in my flowers, so could be like an interesting use case. Well, I am from Guatemala. I'm Sergio Mendez, as I said. So in Guatemala, there are a lot of farmers. So I think that my country, I think that needs edge computing to locally process that information about their plants and that kind of things. So you can use, for that kind of countries, smart farms, smart gardens are like a really nice idea to implement. You can use this kind of systems like alert systems, security cameras, let's say. You can implement a security camera at your home, check if something is moving there, detecting objects, recollecting information. Maybe you want to implement something that stop your dog when the door is open. Maybe you want to implement something like that for edge computing. I remembered some talk here at Civo Navigate that they were talking about federated learning. So the different edge devices in different locations, or maybe let's take as an example Civo Navigate. Maybe could be like different edge devices in the theater, in the rooftop, and everything. And maybe you are sending information about how it's going, the talk about some speaker, or get information on how many people, and you want to get all the information together and show it in a Grafana dashboard in the main entrance, let's say. So we can do that with edge computing without using Wi-Fi. Maybe we can use another kind of protocols like LoRa that can send information across, let's say, from 1 to 10 kilometers using one battery, just with that, instead of using a Wi-Fi or an expensive kind of Wi-Fi connection to send information. You can also use edge computing to recollect location information like GPS coordinates, like, for example, your car is moving and is getting the information like the Waze application, but Waze uses or the smartphone as the edge device. Let's say that Waze is an edge computing system, but a bigger one. So you can implement a geolocation application, GPS applications, that is the same. Forecast, that is something that we are going to do. Well, not to predict, just getting the information, but you can get that information to create a machine learning model to predict how it's going to be the weather in some days. So maybe you want to buy a farm, and maybe you want to monitor your farm remotely just with that edge device. So it's one of that use case applications. If there's something new here, well, Kubernetes in that context is a powerful tool that can help you to create a distributed system. A distributed system is a system that is created with a lot of machines, maybe more than 20 machines in different locations, but this thing is going to have these machines in different locations and not all together in a data center, let's say. So Kubernetes is going to give you the power of that. Some people that just know about edge or hardware tools like Arduino or something more in depth, can you take advantage of Kubernetes to create your distributed system, to automate how to update that edge applications in your device. So that's the benefit of Kubernetes there. Like pushing that people to start learning best practices of DevOps to implement their systems, let's say, but it's more than that. K3s, as we know, Civo is made with K3s inside. Kubernetes is a lightweight Kubernetes called K3s. Civo is an example of a cloud that is using K3s. Well, I think that maybe it's like, maybe the unique big cloud that is using K3s right now. The bigger and the stable, let's say maybe the stable one. Who knows that there's another cloud. So I use K3s to run on my edge devices. In this example, I am going to use a Raspberry Pi. You are going to see my Raspberry Pis now. So K3s is really nice. Has all the features in one single binary that is like 100 megabytes. It's pretty small, and includes the Docker and all the things that you need to run Kubernetes. K3s eliminates all the unnecessary things to run your cluster. It's designed to run or bare metal on your hardware, on your small devices. Has like some interesting tools like using MySQL instead of etcd to have that information. Maybe you can have that information in the cloud. Instead of the local etcd, maybe MySQL on the cloud hosted on GCP, Azure, or AWS, wherever you want. So K3s includes all the things you need. K3s is a CNCF sandbox project right now. And as I mentioned, Kubernetes can give you the whole automation to your applications and the scaling power to your system. In this case, for edge computing. ARM In the other side is like a microprocessor that is not as powerful as Intel, but consume less, less energy, let's say. So it's like cheaper for the edge devices to run just with a single battery instead of Intel. Maybe a battery with ARM can last like 3 hours, let's say, and Intel only 30 minutes, just to give an example. It's not the real information, just like, but it's different. Intel has more power, but consumes more energy. A Raspberry Pi, this is an example, a non-production example, because a Raspberry Pi was created for learning purposes, for prototype purposes, but some people use the Raspberry Pis for production. So, okay. So, well, there are like different things, different cluster configurations, single cluster and everything, and there are different challenges, as we mentioned, the energy consumption and that things. So we are going to show the temperature and humidity on real time, something that you can apply to measure at your garden with your plants and flowers. So let's create your system. I am using Ubuntu, a Raspberry Pis, some micro SD cards for my operating system, a switch, and a Key Studio Raspberry Pi starter kit with a lot of electronic stuff. You install all the things, prepare your Raspberry Pi there. You install K3s with a single line command, and another software that you need to run the things. Then you install MySQL and the Grafana dashboard and my Edge client. But how it looks? Well, I have a picture here, maybe not to show the thing with the camera, but the same picture is all the stuff that is running right here. The Raspberry Pi, the sensor that I am using, but how my system is designed. Well, just explaining here, the DHT11 sensor is going to pick information using Python, and with this send Python script is going to send a request to a deployment that is deploying in my K3s cluster, and that information is going to be written on MySQL, and Grafana is going to read from the information from that MySQL. So, so let's do it in real time. So right now, this is my cluster running the Grafana dashboard. And let's run the client again. So it's like showing the temperature using Celsius and the humidity, right? Here is, let me see. Okay. Here is the temperature in real time. Let me touch a little bit the sensor just to update the information there. You are going to see a little bit, a small change there. Yeah, right now, because I am humid, let's say that I affect the sensor directly because I am touching that. Even the temperature is going to change in some seconds. The red line is the temperature. The humidity is like more clearly that, well, I am touching the sensor. So you can do this in different locations, share data between the cloud and locally. It depends on your use case and what it works better for you. So just to see something that all the people knows, MySQL, a small query there. So just creating a small API to store that information, reading from the sensor, and that's it. You don't need more, not complicated stuff. I think that's the power of edge computing. If edge computing sounds a little bit weird, it's like, well, it's not true. It's like easier as we know, it's like just move the things locally, not in the cloud. Well, you can share the things and the information with the sensor. Well, maybe the challenges are the sensors and that kind of things, but it's like something that we learned in the university. So, for example, for me, well, I written a book about this thing, and I was starting to play, well, let's buy a sensor and play a little bit with that, and it was not like too complicated. Maybe the problem is to create this system on a production way, resist to the weather, bad conditions, and that kind of thing. That's the challenge, right? But design the system, the same concept, distribute system. What is right now most used for distribute system? Kubernetes. How I can update my applications? Docker. So, well, if the speed is necessary, maybe I have to program using assembler or that kind of things. But you can even use maybe just Docker, or, but you can take advantage of that kind of software. So I think that that's it. Let me continue with the presentation. So this is the GitHub repository that you can check with all the code samples, the YAML files, the Python code, even the Python code, the slides, additional resources. The last one is a full video that includes all the things that you need to deploy your own Kubernetes cluster. And okay, just 1 minute. Let me show you a little bit this. Well, the YAML files. Just the Python code is an easier one. A few lines, just calling an API, just that. It's not a hard magic behind, so it's like really easier. And because a lot of you know about Kubernetes, just deploy a database with a persistent volume, a service, a load balancer service using MetalLB for bare metal, and that's it. There's not like more complicated magic behind. And of course, because, well, a lot of this content was an extract from my book. So maybe if you want to check a little bit more or play on weekends, this kind of technologies, you can take advantage on the book. That was like really interesting because I take some portions of some chapters to create this demo. I was like, literally open my book and, well, I am going to play with this. I need these command lines, this example, and mixing a lot of things. So if you want to contact me, that's my email and my Twitter account. I constantly post a lot of things about edge computing, like small tips, let's say, how to use observability on edge computing, what is K3s, and that kind of things. And in the future, I'm going to create some videos about these things. So that's the idea. I don't know if you have questions about, for example, well, let me show you. Okay. Here is all the stuff there. Okay. You have questions, what I use, or?
Two questions. If you try to use Raspbian, which is more suitable for Raspberry Pi instead of Ubuntu, and to install K3s, did you use Kchup, or that is the binary which installed for you K3s, or did you go to the website and just use the normal, the standard procedure?
I think that, well, let's say that I was like experimenting like almost for 2 years about this. Raspbian has their own benefits, but they don't have like a lot of support for ARM 64 architectures. That's the reason to use Ubuntu. It's more like more production ready for harder things. But well, Raspbian has all prepared for you. But in order to get Ubuntu in the same way, you have to copy a lot of things for Raspbian, maybe libraries precompiled for Raspbian and use it for that 64 device. So I think that Ubuntu is more suitable for production-ready environments. Yeah. You have another, okay. Sounds ironic, but it's the reality.
That's interesting that you mentioned people run Raspberries in production. That's what I did at my former place. It was, I told to you, a meat processing factory, and we had the Revolution Pi with industrial grade casings, because that's the difference when you say, okay, it's a Raspberry, but why is this so expensive? Because they made they call it industrial grade casings, so you can put it into the factory against water protected and whatever stuff, and really looks like a science fiction piece. You have to look this, it's called Revolution Pi. And at the end, it's really just a Raspberry inside, so very interesting. And they use it, for example, to connect machines who are not having the protocol, because some machines, they have old protocols and they are not suitable anymore for the new world. So they use this just to translate serial interfaces and so on to TCP, for example, to then get more information of the machines out.
Yeah, that's true. Yeah, there are a lot of devices that you can use. For example, Rock PI is like cheaper, Orange PI. They are pretty similar. So the goal is like use an operating system that supports ARM and you will be fine. Yeah. So any other question? Okay. No way.
Really cool demo. Very exciting. Do you have the list of components? Like if I want to build that as an experiment for me, as a noob in all these things, are there somewhere?
I think that the list
Like which sensors to order and where to like?
yeah, I
if I
think that
wanna
the DHT11 is like pretty common sensor that you can find in any place. And then just like maybe follow the Raspberry Pi tutorials to read the information from the port. And well, but in the code is inside, so in the GitHub repository is all the code that you need to run that part. And I think that is not complicated a little bit. If not, well, extended guide is my book. No, just kidding. Yeah. No. Let me.
No soldering, I hope.
You can buy these speed boards. You can buy them on Amazon with
With everything included.
transistors and so on. And then the thing, yes.
Yeah. For example, in this picture, well, it's like a converter. Let's say instead of using all the pins, it's like a converter to put that thing in your in that place, and just three threads to connect the sensor. A pretty small diagram, just 3 threads there, 3 cables, connect the thing, and then just install the libraries, run the Python code, and
The question is, where do you get Raspberries nowadays?
yeah, I think that right now they are pretty expensive right now. Yeah, I want to try the Rock PI. I think that this is a pretty interesting project, or maybe Orange PI, more expensive. More cheaper, sorry. Another question? Okay. You don't, okay.
Sorry, I got a question.
No, go
On
ahead.
I saw you were disabling the load balancer, or I'm sorry, the traffic portion of it. Was it conflicting with like MetalLB at that point, or?
Yeah, I use a MetalLB, yeah.
Okay. All right, thank you.
Yeah, so for example, that's like the big question for running the things at the edge, how to manage the load balancer. MetalLB is one of that pieces of software that you can use. There is another one created by CubeSphere that is like ELB or something like that. You can even use that, and I think that runs pretty stable. I was like, but as you can see about the networking, I created that network there, but you reserve some portion of the network just for the load balancer IPs, because the IP of the load balancer is higher, starting with the 100, and the IP addresses that I am using for the nodes are lower at the beginning, let's say. So you can specify the portion of the network that you can use to assign IP addresses for the load balancer, and that thing is like creates a virtual IP addresses that you can ping inside the network. So that's the way that MetalLB works. So yeah, that's the trick. Another thing, I think that another challenge is like my internet connection. I don't know why K3s like ask for internet connection if this not some internet connection, maybe I'm missing some configuration there, but it's like the cluster doesn't get up, but maybe it's just, maybe I am missing something or I have to remove something, but you have like to configure your network inside your devices in order to get the internet, and if the internet is changing and all the things, because Kubernetes is waiting or expects a pretty stable networking. But right now, I have a different networking. I am running the thing with my smartphone. So my smartphone is giving like all the internet information and the connection to install the thing. So it's a little bit tricky to configure your device for a stable internet connection, but it's possible. You are looking this that is running. I'm not using the wireless here, just my internet from my smartphone. Yeah. Okay. Yeah. So yeah, there are solutions for that. I think that is one of the challenges of edge devices. And your question.
Oh, I was going to ask if you tried running this on like Raspberry Pi 2Ws or anything to that effect, but I looked up the prices and those are like $65 average now too. So it's like, man, never mind. Rock Pies it is.
Yeah, I think that if you found something that is using ARM, you can try it. So it's not like a big deal. Maybe the only thing that you have to do is recompile the container for a different architecture, but not like a big deal. Well, it depends on what programming language are you using. Python maybe is a little bit complicated. With Go, it's easier to change the architecture. So yeah, so in that way, you can decide which language is better for you. Yeah, I used Python just because Python is easier to understand. But there are another kind of languages like, well, TinyGo is an optimized Go language just for edge devices. So you can use TinyGo. I think that's it. And thank you for assisting to my presentation. Thank you very much.